Okay, guys, here is your notes video for section 1.5. Looks a little different today because I forgot my iPad, but I think this should work just fine. I have here your section 1.5 notes. This is actually 4 pages, but we're only going to do the first 2 today. So this last page, the last 2 pages anyway, are compound inequalities. So let's just talk first about like regular inequalities. Okay, so this first section of notes is on graphing inequalities. Okay, so we're going to use a closed, I'm not used to using the stylus. Okay, use a closed dot for if we have like a less than or equal to or greater than or equal to symbol. Okay, and we're going to use an open dot for less than or greater than symbols. Okay, so note the difference here. One is less than or equal to, and one is just less than. Okay, so the equal to, you probably can remember, is it means that whatever value you're talking about being less than or greater than, it can also be equal to that number. So it's an equal sign and a less than or greater than sign. Okay, so interval notation. This is the way that we write these solutions. Okay, you use infinity symbols, parentheses, and brackets. Okay, so just like how we used a closed dot for just how we use like an open dot for just less than or greater than, it's not including that value. We're going to use parentheses for those. Okay, parentheses for the values that we're not including, and then we're going to be using brackets for those that we are including. Okay, so there's 2 things you need to remember here about graphing. We're either going to use an open or a closed dot on the graph, depending on whether we include that value or not, and then the parentheses and brackets, depending on whether or not we include that value. Okay, just giving a big glare. All right, so let's look at graphing these 2 examples here in number one and number 2. So it already gives us, like, this is what your solution is going to look like. X is greater than or equal to 8. Okay, so then we'll number this. I'll just put 8 in the middle here, and then we'll say 9, 10, 7, 6. Okay, so we have a number line that shows 6 to 10. 8 is in the center. It doesn't always have to be, but it's just a good idea to do it that way so you can really see what's going on. Since there is a greater than, x is greater than or equal to, we're going to be using a closed dot. Okay, so right above here, it's going to be a closed dot. Okay, and then x is going to be the values that are greater than. So we're going to go, our arrow here is going to go to the right. Okay, so that's that graph. And then in interval notation, we look at, in these brackets and parentheses, what we're going to be putting is the smallest number it can be on the left, and then the biggest number it can be on the right. Okay, so x is greater than or equal to 8. It means it can't be less than 8. So 8 is going to be the smallest number it can be. So we're going to start with writing 8 here. And it goes on forever. It can be as big as you want it, as long, the only condition is that it's greater than 8. Okay, so it's going to go on to positive infinity here. All right, infinity is not a number. It's just kind of the direction that we're going. We're going in the positive direction forever. So because it's not a number, we can't include infinity in our notation here. So we're just going to have that open parentheses, and then for 8, since it's a less than or equal to 8, we're going to have the brackets. Sorry, it's a little squished up here. I'm not used to using this writing stuff. Okay, let's look at number 2. I wonder if I can So, oh, there we go. Let's zoom in there. Oh, but then I don't have my, I can't zoom back out. There we go. Sorry, guys. Thanks for hanging in there while I figure this out. Anyway, okay, that's not going to work. Okay, so A is less than -1. Okay, so the first thing that you can do, even if you're not really sure where to go, is we'll just label our number line here. So let's start -1, 0, 1, and then to the left we get -2 and -3 here. So our dot is going to be above -1, and because it's just less than, there's no equal to, it can't include -1, but it includes all of the numbers right up to -1. So the way that we show that is by drawing an open dot over -1. Okay, that's open. Let me do that a little bit better. Open dot, there we go. And then it's going to be all the numbers less than that. So our arrow's gonna go here in the negative direction. Okay. So interval notation, let's write the smallest number it can be. Well, it goes forever in the negative direction. So that smallest number we're going to represent as -infinity, comma, and then the biggest number it can be is -1, right? It can't be greater than -1. Always with infinities, we're just going to use the parentheses because we can't include that number. And then because the -1 has it doesn't have an equal to underneath it, it's not equal to -1, it doesn't include that, so we're also going to use the parentheses over here. Okay, oops, shoot, that's not what I wanted. I don't know how to get out of here. I don't know what that means. I just archived this. Great. Oh, there we go. Okay. Sorry about that, guys. All right, so let's look at solving inequalities. So solving inequalities is very, 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 very similar to solving equations. There's just one main thing that you have to keep track of because the sign points to one way or the other. So you follow the same rules to solve an inequality as you do an equation. The only condition is that you switch the sign. You switch the inequality symbol if you multiply or divide by a negative number. Okay, so we can look at doing that here in one of these problems. Okay, so let's look at problem number 3 first. We have 5v plus 1 is greater than 7v minus 17, okay? So let's go about this the way that you would just go about solving a regular equation, okay? So first we want to get the variables on one side. So we have 5v on one side and 7v on the other. So let's just subtract, to keep it positive here, let's just subtract 5v from both sides. On the right side, we're going to get 1 is greater than 2v minus 17. Then we'll add 17 to both sides to get that 17 away from the v. Then we have 18 is greater than 2v. Then we're going to divide by 2. Divided by 2, we get 9 is greater than v. Okay. I always like to write it with the variable on the left side, so I'm just going to write my answer as v is greater than, no, v is less than. So if we switch the sides that the variables are on, we have to flip the sign as well. So v has to still be less than 9. Okay, so let's draw our graph here. So 9, 10, 11, we'll do 8 and 7. It's going to be an open circle because it is not equal to 9, it's just less than. So open circle, and it's going towards the smaller number, so we'll do an arrow pointing left. Interval notation, the smallest number it could be is -infinity. And then the biggest number it could be is 9, and we're going to just be using parentheses for both of those because we're not including either of those numbers in our final answer. Let's take a look at number 6 here. Scroll up some. I don't know why that's doing that. This thing is so annoying. Okay, so number 6 here, we have 3 minus 4m plus 1 is greater than or equal to 5m minus 25. Okay, so the first thing that we're going to do is we're going to distribute, right? And what we're going to distribute is this negative here. So we'll write this as 3 minus 4m minus 1 is greater than or equal to 5m minus 25. Let's get all the variables on one side. Since the m is negative on the left side, we'll just add 4m to both sides. Then we get 3 minus 1, which is 2, so we're left with 2 is greater than or equal to 9m minus 25. We'll add 25 to both sides. I'm just going to move it down here. Then we get 27 is greater than or equal to 9m. Then we'll just divide by 9m, divide by 9, and we'll get 3 is greater than or equal to m. Okay, so we'll draw our line here. We have 3, 4, 5, 2, and 1. We have a greater than or equal to sign, so that means our circle is going to be closed. So let's draw a closed circle above the 3 here. And then m is less than 3, so we're going to be going in this negative direction here. So the smallest number is going to be going in the negative infinity direction, so we'll just write negative infinity. The biggest number it could be is 3. Negative infinity gets the parentheses, as always. 3, since we can be equal to it, it does include 3, and we have a closed dot. We're going to use this bracket on this side. Okay, so hopefully that can get you through most of these problems up here. I'm going to stop the video now because I don't like how this is working. I'm going to grab my iPad at lunch. So I will post a video with some more examples on how to do these, and hopefully that will be good for you guys. And then I'll also post a video on how to do the foldable that goes with these and the solutions to the foldable. Yeah, I think that's it.